If you interact with APIs, you probably heard of JSON Web Tokens before. This compact way of exchanging information made its way into most of the major web frameworks out there. And if you're wondering how to parse and validate JWTs in Python, you came to the right place. I'm Justin Paral, a developer advocate here at Zero. If you need to understand the basics of JWTs, I recommend you watch my previous video on how to create JWTs in Python, linked in the description below. And without further ado, let's write some code. I already created and activated a Python environment. I already have PyJWT and IPython installed. But if you need to install it on your env, you can do it by running this command. This will install all you need. So PyJWT is the most popular library for dealing with JWTs, and we are going to use that today. And IPython is an interactive Python console. It has a few features like code completion and syntax highlighting that I really like. But feel free to choose whichever interface or Python console you prefer. So let me clear this and start my console. IPython, and I'm going to import JWT. Now, I already have a token that I want to verify the signature. Let me copy that, and it is this token here. And with PyJWT, this will take one simple line of code. Yes, only one. You just need to use the decode method from the JWT module and pass the token and the secret, and that would be it. So this would be jwt.decode, my token, the secret, and the algorithm used for signing the token. Of course, this only takes one line of code because I already know everything there is to know about this token. And you can note here that the output of this command is actually a dictionary with the payload of my token. And this is printed out because this token was successfully verified. So that's the only way you can see the payload. So I will show you what happens when the verification fails in a bit, but let's say you don't know how this token was generated, right? So one thing that you could do is copy this token and paste it on our friendly JWT.io. And here's JWT.io that I opened in my browser, and it already has an example token. I can paste my new token here, and you can see the header, the payload, and that the signature is not verified because I didn't fill out the correct secret for this token. But what if you want to use Python to check this out? The way to do it is actually using PyJWT once more. And let's go over how you can do that. Because PyJWT is such a nice tool, there is one method for decoding the header of the token. So instead of going to jwt.io, you can get the header without actually verifying the signature of the token. And believe me, you could do this manually by taking the part of the string that has the header, decoding it, turning it into a dictionary. But this would take 2 extra modules and a few lines of code. So I don't want to do that. And Python JWT actually gives me a method to do that. So let's see how that works. So instead of using decode this time, I'm going to use jwt.get unverified header, and I'm going to pass my token. And now you can see here my header. It is also a dictionary. And if I store this header into a variable, you can use that to make your scripts a bit smarter. That's awesome, right? So let me do that and do header data equals what is the result of get unverified header. Now I can reuse this to decode my token. So if I come here, and because this is a dictionary, I can access the algorithm. Let me make this a little bit bigger so you can see the algorithm by referring to the dictionary and the algorithm key. And if I run this, you can see the same payload once more. And just like that, looks like magic, right? And so far, you may be saying, okay, everything's rainbows and unicorns, everything works. But we know that real life isn't like this, right? So what happens if my token doesn't get verified? Let's say, I don't know, it expired. So let's see how you can deal with failing in verifying the token itself. What happens is when you try to verify a token that is not verifiable, for instance, an expired token, PyJWT will raise an error. So I got another token that I can use for this, and let me copy that. And I'm also going to copy the code that I already got. Okay, so this token here actually has an expiration date set in the past from today. And because it is expired, when I try to decode it, it's going to give an error. So let's see what happens. And you can see here, it gives me the expired signature error. And if I scroll up, because IPython shows a very detailed traceback, it shows the error happened when I try to use the decode method. Awesome. But now that you know that, how can you handle this in your scripts? So one way to do it is actually using the errors that comes with PyJWT. And what I can do is actually importing them from the exceptions module. And I'm going to import this expired signature error specific error. And now I can do a try except clause to deal with this error when they happen. So my code would look a little bit like this. So now you can see here that I have a try. So it tries to decode, and then it fails because of the expired signature error. It prints out an error, a friendly error. So if I run this, and you can see here that instead of having that enormous traceback, I can see that the signature is expired. Awesome. Now, if you need more details on the steps that are required for validating or verifying your tokens, I recommend you read Auth0's documentation on the subject that is linked in the description below. Now, before I finish this video, I want to make sure that you know how to verify the signature of your token if we use an asymmetric algorithm. And if you don't know what that is, that's okay. An asymmetric algorithm like RS-256 is one algorithm that uses a private key for signing and a public key for verifying the signature. So let's do just that. I already have a token here. Again, I'm going to clean this script because this token is a little bit big. And this was signed using RS-256. So let's verify the signature of this other token. So the first thing I need to do is actually read the public key so I can do the verification. So I already have my public key inside of a .ssh folder in my working directory. So you can see that here. So that's that. And I can read it and store it in the public key variable because I want to use it. So the first thing, I open it and then I use the method read so that I can get the bytes version of this key. And after that, I need to do two more steps. So it is important to know that this particular key was generated using SSH keygen 2. And because SSH keygen 2 uses a particular encryption algorithm, I'm not going to go over right now, but that means I need a specific method to be able to load this key and use it. So that takes me to the second step after this one. That is to import the method I need to use to read this key. So this comes from the serialization module from the cryptography package. And the way to do it is actually do from cryptography, and I want the module hazmat primitives, and I can import the serialization. Now what I need to do is actually load this key using the serialization module. So to do that, I'm going to save my key into a key variable because I want to use it later. And I'm going to call the serialization dot load, and you can see here I have a number of loading methods, and the one that I want is actually SSH public key. So what I need to do is pass the bytes version of my key, because the read method gave me a string and the load SSH public keys actually requires a bytes object. So the way to do this is using encode the string built-in method. So I'm going to do that here, and once I run this, I get the loaded version of my public key. And now I can use this key to actually verify my token. So let's do that once more. And I'm going to copy my code for my notes. And now I got it. So you can see here that instead of using a secret, I'm now using my key, and I updated the algorithms list to reflect the algorithm used. And now you see the result of my verification. And that's it. You just verified the JWT signed with a symmetric algorithm. Yay you! That's all for today, folks. Now you know all the necessary steps needed to validate your JWTs in Python. If you have any questions and want to see more videos like this here in the channel, leave a comment down below. Also, remember to subscribe to the channel and check out the link section in the description of this video. There you'll find a link for the GitHub repo with all the code that I showed today, a blog post on the same topic, and a link for the JWT handbook in case you need more in-depth resources on JWTs. Thank you for watching, and I'll see you soon. Bye!